Okay, here's where we left off with last video. I just want to go over number 4 again. It is one of the more difficult types of questions, these double replacement. You have to use this other part of the predicting products handout. And again, for a double replacement reaction to occur, at least one of the products must be a solid, a gas, and I told you I won't give you any examples that produce a gas, or water. It could be other covalent compounds, but again, I won't give you other covalent compounds. So, solid or water is what we're looking for. And we went through and we looked at our first compound here, aluminum nitrate, and I found a rule, one of these solubility rules, that applies to nitrates. And I found that here, the third rule, all nitrates are soluble. Now, in case you don't remember what soluble means, I put the definition right on this handout. Soluble means it will dissolve to form an aqueous solution. So it will dissolve. So I put AQ behind it. So all nitrates get an AQ behind it. Next chemical is calcium sulfate, that compound, and I find a rule that works for that, and here it is, the fifth rule down here. All sulfates are soluble, except when that sulfate is with silver, lead, or something from group 2. And if we look at a periodic table, group 2, and by group 2 I mean the second column of the periodic table. So beryllium, magnesium, calcium, strontium, barium, radium. Now any of those, if we have those with a sulfate, and we do, calcium is one of those group 2 elements, this rule doesn't apply. So it says all sulfates are soluble except when they're with group 2 elements. So it's an exception, so it's not soluble. And up here, again, I gave you the definition. Insoluble means solid. So that's why I have the S there, and that's why I have the AQ there. You only have to do this for double replacement reactions. It's kind of tricky. It's a lot of work. All this stuff will be given to you. This handout will be given to you on the test. You don't have to memorize. You just got to know how to use this handout. But again, that's only for double replacement reactions. So let's move on and do some more examples here, because the next one is not a double replacement. The next one, we have, again, carbon and hydrogen together. I see that. Oh, I see it with oxygen. I know automatically that this is a combustion reaction. Once I know it's combustion, I automatically CO2 plus H2O every time. The next one here, if I look at number 6, the only thing I have here is a compound. There's nobody else here. So think of it as a couple dancing. If nobody else is there, either they can dance together or they can split up. And that's what they do. This is a decomposition. So we have a compound here. Nobody else is in the picture. And what they're going to do is they're going to break up. And it's going to be aluminum and oxygen. Now, like I said before, if we have a compound, we do the switch trick. If we have something that's alone, the only thing you have to do is check, is it one of our 7? And if we look at it, aluminum is not one of our 7 diatomics. So I'm just going to leave it Al. Oxygen is one of my diatomics, so I'm going to put a 2 there. And that is a 2, not a Z. There we go. That looks a little more like a 2. Now notice the 2 and the 3 from over on the left side of the arrow don't automatically come over. Again, the only time they can do that is if they're inside parentheses. Number 7, we have aluminum that's all alone, and we have hydrogen and sulfate. Again, sulfates from your what is it called now? What is that thing called? Polyatomic ion sheet. That's what it is. Sulfate is a polyatomic. So we have a couple dancing, hydrogen and sulfate, somebody alone. I know that is single replacement. And once I know it's single replacement, I know I have to look at my handout again. So this time we're going to use the left side, the single replacement side. I have aluminum, and aluminum is on the left side of the stairway on the periodic table. Aluminum's right here. Here's the stairway. And if they're on the same side of the stairway, they will replace each other. So hydrogen is here, aluminum is here. They're both on the same side of the stairway. I could also double check by looking at the list. Aluminum is here and hydrogen is here. So they're on the same list. So the aluminum isn't going to try and replace the sulfate is what I'm trying to get at here. So aluminum, what we have to ask ourselves is aluminum cool enough to kick hydrogen out? And let's look at our list. Here's hydrogen. Here is aluminum. Yes, aluminum is the cooler element. So what happens is, since aluminum is cooler, it's higher on the list, aluminum's going to come up and say, hey, hydrogen, get out of here. I'm going to dance with sulfate. And what we end up with is hydrogen all alone plus aluminum and sulfate dancing. Remember the 4 is in the parentheses, so it came over. That 2 behind the H was not in the parentheses, so it did not come over automatically. So what we have to do here, we have something alone. Is it one of our 7? Yes, hydrogen is one of our 7 diatomics, so I'm going to put a 2 there. Here we have a compound. Whenever we have a compound, we do the switch trick. If we look up aluminum on the periodic table, it's a +3. If we look up sulfate, it's a -2. They don't add to 0, so I'm going to do the switch trick. The 2 goes here. The 3 is going to go on the outside of the parentheses. So this reaction will occur because aluminum was cool enough to knock hydrogen out. Hydrogen's alone, H2 plus Al2SO4, 3. And you'd want to balance that. Again, I'm not going to balance it just for the sake of time here. I'm going to scroll down here and do the last batch. Next one. This is another double replacement. We have a couple dancing. We have sodium and bromine dancing and lithium and nitrate dancing. So I know this is a double replacement. And since it is a double replacement, I know to look at my handout. We're going to use the double replacement side. And first thing I'm going to do is I'm going to figure out what the new dancing couples are going to be. I always like to start with the same order, so Na, but instead of Na dancing with Br, Na is going to be dancing with NO3. Again, I'm switching the second part of each compound and leaving the first parts alone. Plus lithium, and instead of lithium dancing with nitrate, lithium is going to be dancing with bromine. Now, if it's in the beginning of the compound here, it's going to have to be in the beginning of the compound here. If it's in the end of the compound here, on the left, it's going to have to be in the end of the compound here. One thing you always want to remember is we always write compounds, the positive one first, and then the negative one second. And if you look up the charges of lithium and bromine, lithium is a +1, bromine is a -1. Again, let me double check that on our periodic table. Yep, lithium is a +1. Bromine is a -1. We're good to go there. They cancel out. Sodium. Sodium is also a +1. And polyatomic ion sheet for nitrate. Nitrate is a -1. So both of these are +1, -1. Makes it easy. Because they cancel each other out. You don't have to worry about doing any little switch trick things. But the last part for double replacement, and this is the tough part of a double replacement reaction, is we need to use these rules. Now, this first chemical, sodium nitrate. Rule number 3, all nitrates are soluble. And again, if I forgot what soluble means, it says it right here. I put an AQ behind it. Now, this next one, lithium bromide. There's actually 2 rules on here that apply to lithium bromide. And this first rule, it says all compounds with a group 1 element are soluble. And this actually applies to both these chemicals here. Group 1 is the first group on the periodic table. So hydrogen, lithium, sodium, potassium, rubidium, all these. So if I didn't use the nitrate rule for this first one, I could have used the group 1 rule. The other rule that applies to LIBR is this one here, the fourth one. It says all halides are soluble. And if you look at the bottom of your predicting products handout here, I have some more definitions here. Halide is anything that contains something from group 17, a halogen. If you remember back a while ago, we learned those as the halogens. Group 17 on the periodic table here is fluorine, chlorine, bromine, iodine. Well, bromine is one of those. So there are two different rules. They would get you the same answer. It doesn't matter which one you use. I think it's easier just the group 1. So anything in group 1 is soluble. So lithium's in group 1, so it is soluble, meaning AQ. Now, technically, this reaction won't occur because, if you remember, for a double replacement reaction to occur, at least one of the products must be a solid, a gas, or water. Neither of these are solid, neither of these are gases, and neither of these are water. So technically, I would want to write no reaction for that. But again, this is the toughest type of question you're going to have here on this topic. It is a fair amount of work. They aren't all this much work. And what I might do here is, if you want to pause it and try the next 1, 2, 3, 4, I will put up the answers for 9 through 12, and you can check them. So pause the video now, try 9, 10, 11, and 12 on your own, and then unpause it, and you will see the answers. Okay, here are the answers for 9 through 12. The first one, we have two single things, two elements, and I know that's synthesis when you start with two simple things, and what you do is you put those two simple things together. And hydrogen and oxygen, I know hydrogen is a +1, oxygen is a -2, so when I do the switch trick, the 2 goes there, the 1 goes there, I end up with H2O. The next example, Na2O plus K, so I got somebody alone, and I have a couple dancing, so I know that's single replacement. And what's going to happen is the K is going to try and come in and knock out the Na. Sodium and potassium are both metals, and metals replace metals. And let's look at my list here, and I looked, and I found potassium here, and I found sodium here, so potassium is cooler. So when potassium comes along, oxygen's like, oh, I want to dance with potassium. He or she is so much cooler than you, sodium, so get out of here. So sodium is all alone, and potassium and oxygen are dancing now. Now, if they're alone, we ask ourselves, is it a diatomic? Na is not. Now, I made a compound over here. K is a +1, oxygen's a -2, so I did the switch trick, so I put a 2 there. Next one, N2O5. Well, it's just a compound. The only thing it can do is split up. And it's going to split up into nitrogen, oxygen. Both nitrogen and oxygen are diatomic, so I put a 2 there. Notice I didn't automatically carry the 5 over. That would be incorrect. And lastly, number 12 is a double replacement, two couples dancing. I make sodium and carbonate, and again I did the switch trick here. +1 for this one, -2 for that one, switch trick. And I'm left with HOH, which is water. And remember, one of our reactants, or our products, must be water for the reaction to occur. And again, I use my rules. There's group 1, Na is in group 1, so I know it is soluble, so I put AQ, because Na makes it AQ, because Na is in group 1, and group 1 elements, group 1 compounds are always soluble. And liquid is, or HOH is just, I'm going to assume, a liquid. So we will do some more practice of this in class, but hopefully you're getting it, and take the practice quizzes. Good luck.